Welcome. We're here. We have some visitors from last year. Christina's here. Fred?
Hi.
Fred's here. Who else here? Russell's here. I don't remember your first name. Morgan, I knew that. I knew that. Anybody else? Is that it?
That's it. Yeah.
We also have a visitor. What was your name?
Ashley.
And we have Ashley's a visitor. Okay, and we're here making part one of exam review, midterm exam review, okay? And the students are here. I have a lot of students. Excellent, Lana's here. And we want to, the first one, we're gonna follow the questions on the back of midterm exam review guide outline. What is speed and velocity? Anybody? What is speed and velocity? Right? Speed and velocity. Well, it's meters per second. Okay, it's distance over time, correct? Distance over time. But what's the difference between speed and velocity? Anybody know? Anybody? Yes, Brett.
Velocity has a direction.
Velocity has a direction. Magnitude and direction. And the speed just has magnitude. Now, that's a very good point. That's a very good point, Peter. Excellent. Because if it just had direction, this is a question for you to look up. You ready? Extra credit. If something just had a directional change, but the same magnitude, would that also be acceleration? And I'm going to answer that question for you in a second. In other words, if speed and velocity, speed is just magnitude, correct? And velocity is magnitude and direction. Could you have just direction as a scalar quantity? That I'm not going to answer your question, but I'm going to answer your question something else. If you have acceleration, now acceleration changes direction. I could have the same magnitude. I could have the same magnitude for acceleration. I could keep going around in a circle. Same speed, right? Same speed, 20 meters per second. 20 meters per second constantly. But the acceleration we know is what? What is the acceleration? What is acceleration? What is it? What is acceleration?
Meters per second squared.
Change in velocity over change in time, correct? Correct? Change in direction over change in time. Change in velocity. However, if I go around in a circle and I don't have a change in velocity, a change in speed, do I still have an acceleration?
Yes.
Why?
You're decelerating?
No.
It's constant.
What's constant?
The acceleration.
No. Well, the acceleration is constant. Yes, that's true. But why is it acceleration? How is the velocity changing? How is the velocity changing?
You have the constant velocity.
No, you don't have a constant velocity. The velocity is changing, but how is the velocity changing? I have 20 meters per second, and the time is going to be 1 second. Okay, per second. Okay, per 1 second. Correct? But let's say it's 20 meters per second, and that's constant. What's changing if it's going in a circle?
Direction.
What is it?
Direction.
The direction is changing. Isn't the direction part of the velocity?
Yes.
Yeah. The speed can stay constant. The magnitude of the velocity is called speed. But the direction can change constantly, and that's why it's acceleration. So let's review. Let's review. Okay? Let's review. Velocity is distance over time. Acceleration is velocity over time. Correct?
Yes.
But, it's also direction. This just gives you an idea of the magnitude. So in other words, he's going 60 miles an hour. Is that speed or velocity?
Speed.
That's just speed. He's going 60 miles an hour north. He's going 60 miles an hour south. That's velocity. He's accelerating, going in the positive direction. That's acceleration. He's decelerating. That's negative. So you have to have a direction along with the magnitude. Okay? So velocity, acceleration. Yes? Velocity is change in distance over change in time. Yes?
Yes.
And acceleration is change in velocity over change in time. But always think, that's just magnitude. Always think you also have to have direction if you're going to have a vector, correct? End of part 1. See you later.